For demonstration 2, again, we're thinking about what happened in our scenario. So I know that the car started off moving 0. And as I observed it moving, I noticed that it didn't reach a speed near what it reached in demonstration 1. So I'm going to say that it is moving in the positive direction and it is going accelerating, but its final speed is going to be much lower than what it was in the first part. And the reason for that, we'll talk about in a minute. But that is something that I could actually see. I actually viewed that. And because of that then, since my change in velocity is much lower, I know that my acceleration rate is also much lower. So I'm going to draw it so that it's closer to 0 because it's not as steep. My velocity time graph is not as steep as it was in demonstration 1. Now as far as applied force and net force go, again, I'm going to start off and I'm going to say, okay, what does the picture of my scenario look like? And then based on the picture of my scenario, what does my free body diagram look like? And then based on that, what's going on? So I know that this string is providing some force to pull it. I know it's going to be moving in that direction. So when I draw my free body diagram, again, it's necessary for me to identify the agents that are acting on the cart. So I have a force from the earth on the cart. I have the force from the track on the cart, holding it up, keeping it from falling through. Then I know I have a force from the string on the cart, pulling it along the track. And in this case, I told you that now the track is providing some non-negligible force on the cart opposing its motion. So since it's moving to the right, I have this force to the left, which is opposing the motion from the track on the cart. So now when I'm looking, here's the force I'm applying, but that's not the same as my net force. My net force, that's in the accelerating direction horizontally, is going to be the force from the string on the cart minus the force from the track on the cart. And since that's the case, my net force is going to be a different value than my applied force. Notice my net force is smaller than my applied force. So now if I go back here to my graphs, my applied force did not change. I still have the same amount of force on this cart from that string. It's the same. But what changed was this net force. It is now much smaller than it was before. And because of that, since my net force is smaller, my acceleration is smaller. So notice my acceleration depends on what my net force is and not what my applied force is.